Hi everyone, I'm sorry I can't be in there with you today for class, but you should have received instructions from the substitute. You're supposed to try these proofs on your own first. If you have not done that, I've given it at least a little look over and a thought on your own. I do want you to take some time to do that. However, if you have, then welcome, and we'll take a look at the ways that I went through this proof, and the one on the back as well. There are two actual ways to do this proof. I'm going to show you one on here, and then the answer key I post to the classroom will have the full details for the other, but they're really not that different from one another. So, first thing I would notice is that the givens tell me I have two parallel lines. So, once I see that those are parallel lines, I look for transversals, and BF looks like it's going to be a transversal that could be good. However, with the prove statement of JGF equaling FBC, that's giving me knowledge of what triangles I'm going to have to deal with here. And unfortunately, none of the angles with BF as alternate interior or corresponding or anything would help work with that. And JG doesn't even reach from one parallel line to the other. However, CJF does. And so that actually gives me a pair of alternate interior angles. But that leaves me with none of the other angles. So unlike the other day, this isn't going to be a proof where you can just go ahead and rely on angle-angle similarity. We might need to use one of the other methods instead. And so because I marked these angles congruent, I'm going to do BCF congruent to JFG. You could number them, of course, if you wanted to. And I have the parallel lines cut by a transversal forming those congruent alternate interior angles. Because I have that angle pair declared, what I'm going to do is side angle side similarity. And so if I look at the pieces that are forming one of my angles, they are BC and CF. The other pair are JF and FG. So what I'm going to do is I'm going to end up using the things related to those in our givens. So I have BC, I have CF called FC in the givens, I have JF, and I have FG. So I want to focus on those. The other method happens to use the ones I did not circle. But what I'm going to do is I'm going to look at the number values associated with those, and I'm going to be able, with the reason of the fact that just in mathematics you can have ratios that end up being equal, is I can set up a comparison. 13.5 over 9 is equal to 15 over 10. And because those are equivalent ratios, with a substitution property, I'm allowed to say that BC can compare to FG, and that will equal the comparison between FC and JF. And that's going to allow me to now have side angle side congruency. Sorry, not congruency, side angle side similarity. And the naming convention of these triangles I put on here does correspond to what I have here for the substitution property ratios. I have BC compared to FG, and those are the first two letters in each of the triangles. I have FC compared to JF. Those are the last two in the names. And then also the angles were centered at C and F. And so since the angles were centered with those as the vertex for each angle, C and F should be the same in our names, and they are both the middle. So everything is corresponding correctly here. Now just so you know, on the answer key, the other way is to not just do two equivalent ratios, but to do three, and then you would have a substitution with three equivalent ratios but named as sides, and you could have done side-side-side similarity instead. But because I have SAS, that was good enough already here, and it allows me to say corresponding angles of similar triangles are congruent. Remember, the corresponding sides are proportional, but the corresponding angles are still equal since it's dilation based. So that's the end of this proof. If you need to, maybe look through it a little bit more or copy. Again, you might want to go back to the beginning of the proof, so then you can go ahead and copy all of that down or review it in real time. But in the video, as far as we're concerned, I'm just going to move on to our next one on the back. And we should notice immediately that this next one on the back ends up being an indirect proof, and we can tell because of the congruences, the non-equalities that are inside of this. Now, it wasn't pre-printed for the givens because, as you may remember earlier in the year, it's not traditional for us to have those given to us. We usually try to do a different order, but it is okay if we do that, and I know that as a whole my classes preferred that this year. So I went with what you normally prefer, and I got the givens out of the way. That way no givens are forgotten, and they're all present. So we have all of that listed already. Okay, which means I can go ahead and mark on here MLO congruent to LNO. So we have those congruent to each other. And now I look at the prove statement and I see OML is not equal to ONL is our goal. So I'm going to be assuming that OML is congruent so that we can do this in an indirect way. So I'm going to assume that those are that. And I'm going to go ahead and get that into my proof with 2 steps. Either OML is or isn't congruent to OLN is the only 2 possible things that could happen in this situation. And we're going to assume the opposite of what we're trying to prove, that they are equal to each other. And so now already in these 2 triangles, one on the left side and one on the right side of this diagram, we have angle-angle similarity. So triangle MLO is similar to triangle LNO by that. And as we said in the last proof, sometimes similar triangles just let us know that the corresponding angles are congruent, but what I'd want here is that we have corresponding sides in proportion. And you can see that I created this proportion based on the names of the similar triangle with the corresponding pieces. So I have OM, first and third, compared to OL, first and third, ML, first and second, compared to LN, first and second. So this proportion was able to be formed, but this and what we were told in a given as a fact that they're not supposed to be proportional is a contradiction of information. And so that leads us to our last 2 things in every indirect proof, that the assumption is false because of the postulate of contradiction, and then we can write what we were actually trying to prove because of the postulate of elimination. Okay, so like before, if you need to, go to the start of this proof and look through things and copy things down again. But once you have a completed proof, the sub has instructions to get you the homework once they show you you show them the completed sheet. All right, I hope to see you guys again soon, and hope this video was helpful.